So in a conservation of momentum problem, we actually can ignore the force. As long as there's no outside forces, as long as basically every force is between the objects interacting with each other, the impulses will cancel, and we can just look at the change in motion of all the objects together. So the justification for that was in the previous video, and I want to show you just how easy this makes a problem. In this problem, we have two figure skaters who are skating. They have a velocity, they push on each other, and one shoots forward with a certain new velocity. The question is, what happens to the other one? The force is probably complicated. It may not be constant. It may have a very strange function. But since they both got that force, according to Newton's third law, the impulses they had were equal. And that makes the problem really easy to solve. So here's the method that you're going to use. And when you practice this, it's something that you'll really understand. The first thing you do is you write that the sum of all the original momentum is equal to the sum of all the final momentum. So that's what it means for momentum to be conserved. Add up all the original momenta, add up all the final momenta, they should be equal. The next thing you do is you count the number of objects there were before the interaction and after. So in this case, we have two figure skaters holding onto each other. They're moving together. That counts as just one object. So on the original side of the equation, I'm just going to write one big blank. On the final side, they're moving separately, so now they're two objects. Their momenta are just going to add together. Now, each object, since it's mv, needs a space for m and a space for v. And now we just go through and plug in. There only can be one unknown, so whichever one that is, we'll leave its letter there. This is the only part of the problem that really varies between different problems. Here we had one object turning into two. That's called an explosion. But this works for if two people crash into each other and then they move together, then we have two over here and one over there. It works for if two objects crash into each other and then bounce off each other. We would have two both at the beginning and the end. So this is the only part that's really different between different problems. After that, it's just algebra. So person 1 and person 2 added together is the original mass. So 55 plus 75. Their original velocity was 3. One of the persons after just has a mass of 55, and she's going at 5. And the other one has a mass of 75. And he's going at V2F. Person 2 final. And that's it. We just solve. So 55 plus 75 is 130 times 3. That is, 55 times 5 is 275 plus 75 V2F. 130 times 3 is 390. So we'll just subtract over the 275. So 115 is 75 V2F. So we'll divide both sides by 75. Ran out of space there. So V2F is 1.53 meters per second. It's positive, so that means forward. So his pushing one of the two skaters ahead, it slowed him down a little, but he's still going in the forward direction. If he had pushed her fast enough that her momentum got to be very high, his momentum would actually have to be backwards to compensate for it. But that's it. These problems don't get any harder than that. So if you follow all those steps, you'll end up being successful on this.